So the boiling process takes about 90 minutes, and a lot of great things, like I mentioned before, happen during that time. We get to sterilize the wort, we get to evaporate some water and concentrate the sugars, and we also get to balance it out with hops. At that point, the boil is done. What we need to do is get the wort out of the kettle and into the whirlpool so we can separate all of the coagulated proteins and all of the hop material. So we're out of the kettle and we've gone into the whirlpool, and it's just that. It spins the wort around, so any solids will form a cone in the center of the whirlpool, and then we can draw off nice, bright, clear wort from the outside of the whirlpool into a fermenter. Before we do that, though, the wort right now is about 210 degrees. We can't add yeast to that, it'll die, so we have to run it through a heat exchanger. It's a pretty simple heat exchanger, works a lot like a radiator. Hot wort will go through every other plate one direction, and then the opposite direction we run cold water and glycol, which is just a food grade antifreeze that we can use. So we can send 700 gallons of wort at 210 degrees through the heat exchanger into a fermenter at 64 degrees in about 15 to 20 minutes. All the while we're doing that, we're also introducing our fourth ingredient, yeast. So the yeast will enter in through this tube, come into this tea. It'll get blended with the cooled wort and also oxygen, pure oxygen. We can check the temperature here as it gets sent on down to the fermenter. This is one of our yeast brinks. We get our yeast from our other beers. The great part about yeast is it's one of the only ingredients that actually increases as you use it. This is one of our 19 fermentation vessels that we have. We have so many because we brew several different varieties. It's just a lot easier to keep them filled that way. You can see the basic shape, the cone where the yeast settles down into. Here's a good example of what we were talking about before, the CO2 coming off from the fermentation. This is a beer that's been in here for 2 days, so you can imagine it's just now tailing off and getting into those more complex sugars after it's gone after the really simple ones. And this will continue to bubble like this for another 2 to 3 days. And then we'll take a sample and determine how much residual sugar is left and determine if fermentation's done, and then we'll crash the temperature. Another important thing that we use the fermenters for that I didn't mention before is that when yeast ferments, it's exothermic, which means it puts off a lot of heat. It's the brewer's job to try to control that heat. If it gets too hot on us, the yeast can put off a lot of formaldehyde flavors, a lot of really funny different ester smells. The way that we control that as brewers is these tanks have jackets that go around the outsides of them, and we can run glycol or a coolant through them. And it's all on a thermostat. So when the fermentation temperature rises, the thermostat detects it, opens the jackets, glycol goes through, cools it back down again. So we can control the fermentation so it doesn't run away from us and get really, really fruity on us. Now on day 13 or 14, we'll take the tanks, which have glycol jackets around them, cooling jackets, and we'll turn on the coolant and allow the tanks to crash down to 0 degrees Celsius, freezing. The beer won't freeze, there's enough alcohol in it. Basically what we want to do at that point is, again, help the yeast settle out a little bit more. But we want to form what's called a protein tannin complex in there, or a chill haze. Basically what that's going to do is allow the protein to present itself in a form that we can filter out. Protein in beer is not necessarily good. It's great for you, but in beer it can actually add or take away from beer's shelf life. So we want to get as much of that out as possible. So from a fermenter on day 14, we'll run it over into our filter. Filter process is actually pretty easy. If you have a pool, it's kind of like that. We use diatomaceous earth, it's food grade, but it works on the same process. Beer comes in, gets mixed with the diatomaceous earth, gets put over into this vessel, which has a lot of different screens inside, stainless steel screens. The beer gets forced through, the DE stays on the screens, and any protein or yeast that comes through with the beer also gets left behind. So during the process, it'll come out nice and brilliant, bright, clear. So from the filter, we saw the beer coming out into a bright tank, which is right behind me here. At this point, the beer is still or uncarbonated. And the way that we carbonate is we do it externally through this device here. The beer gets pumped out through what's called a Venturi tube, and then CO2 gets pumped in on the other side. It gets forced through really two small plates with really small 0.5 micron holes in it. The CO2 goes almost directly into solution, then we can pump it back into the tank, so in a matter of 15 to 20 minutes we can have 1,200 gallons carbonated. So if the beer after the bright tank and getting carbonated doesn't go to the bottling line or the kegging line, it comes in here. It's also where we get to have a little bit of fun. These tanks in front of us here are storage tanks. We make some pretty strong beers here, in particular our barley wine, which we call hopsquatch. It's about 12% alcohol. A beer that strong needs a lot of time to sort of mellow out, so we'll bring it into these tanks and let it sit in here for a year or even more. So we brew the barley wine in August. It sits in here until next August, and then we'll release that vintage of it. One of the other kind of cool things we've been doing lately is experimenting with bourbon barrels. We made a Russian Imperial Stout, which is about a 9.5% really strong stout, that we peeled off some and put into these old 5-6-year-old bourbon barrels from a distillery called Four Roses in Kentucky. It just adds a really neat kind of bourbony, smoky wood character to it. Just some fun, kind of breaks the monotony every now and then. The tanks in the back are all serving tanks. They're basically giant kegs. They hold about 14 kegs worth of beer. They're pressed with CO2 through the beer pumps you see on the wall, through a trunk line, underground, and over to the taps at the bar. We got the line used probably about 5 years ago. We bought it from a brewery in Pennsylvania that was expanding. We were lucky. It's a great line. It does about 75 bottles a minute. Really low oxygen pickup, which is the main thing you look for in a bottling line. Oxygen is the enemy of beer. The way it reacts with some of the compounds in beer will get it to stale really, really quickly. And it'll start to put off some cardboard, papery types of flavors. So if you can find a bottling line that won't put a lot of headspace air into the bottle, that's what you want. And like I said, we got lucky and found that in a little small brewery in Pennsylvania. Empty bottles go on and they get rinsed, mainly to knock out any dust or any cardboard. The water that we use is sterilized, so it can rinse it and slightly sterilize the bottle as well. From there, it goes off and gets purged. And what we mean by that, it gets purged with CO2. We force CO2 into it to force any of the oxygen or air out of it. Right off of that side, it goes onto the filling head. The filling head will go down, and it counter pressure fills. So it'll pressurize the bottle, and it'll allow just enough beer to go in at the same rate as air is coming out, or CO2 is coming out, so the beer won't foam over. It takes about 6-8 seconds, comes around, gently comes off, and if we're lucky, no foam is coming out. That's what we want. Eventually, that's what we want, is to get foam to come out, and we sometimes have to do that manually by putting a little jet of water into the bottle. That'll cause it to foam up. That foam, which is pure CO2, will drive any headspace air out of the top of the bottle. And then once that's done, we immediately cap on top of that foam. The bottle gets rinsed, and it goes into a labeler, and eventually into a case box. We love the line, and we love bottling. Bottling has a certain mystique about it, but I think I mentioned it before, it's a great technology for 1904. The problem is that oxygen gets into it. There's a lot of expense in bottles as well. They're heavy, they're expensive to ship. You gotta buy a crown, a neck label, a body label, a 6-pack carrier, and a case box. And the alternative, and something that a lot of craft brewers are getting into, is canning. Cans are light, they don't break, they're very good for the environment, they don't spend a lot of gas to haul them cross country. There's no neck label, there's no body label, it's all printed on the can. And it's actually a better way to present a beer. There's no light, there's very little headspace air, and it's just a cleaner, better way to send beer out to the public. Four Peaks is statewide, and we do around 5,000 cases every month.
We like to make true to style beers. A lot of our beers are, our Scottish ambers and our pale ales are true traditional ales that were brewed hundreds of years ago. We try and follow a lot of those same recipes and emulate those beers and celebrate them here at our tasting room.